In this presentation, we are talking about Weizsäcker's semi-empirical mass formula. This is a direct application of liquid drop model. According to this formula, different factors are responsible to justify the binding energy of the nucleus. The factors include volume energy term, surface energy term, Coulombic energy term, asymmetric energy term, and pairing energy term are responsible to reach the binding energy value of a particular nucleus. Now we have to discuss about the terms one by one. First term is volume energy term. Consider two nucleons present inside the nucleus. Then the binding force existing between these two nucleons share an amount of energy U. This describes that each nucleon is having the energy of half into U. If you consider a nucleon present inside the nucleus, this is called as an interior nucleon. This nucleon is surrounded by 12 other nucleons. This is surrounded by 12 other nucleons. As we discussed earlier, each nucleon is having energy half into U. Then this nucleon, which is surrounded by 12 other nucleons, may have energy of 12 into U by 2, which is equal to 6U. So a single nucleon has an energy of 6U. If a nucleus contains a number of nucleons, that is mass number, then the total energy of the nucleus is 6U into A. Now the volume energy EV equal to 6U into A. If you replace 6U by a constant A suffix V, volume energy term, then this is multiplied by A. Then EV equal to AV into A. Now read out this paragraph. Suppose the energy associated with each nucleon-nucleon bond has an energy U. This energy is shared by two nucleons, each having a binding energy of 1 by 2 into U. When an assembly of spheres of the same size is packed together into a small volume, each interior sphere has 12 other spheres in contact with it. This is the situation within the nucleus where each interior nucleon, this is very, very important, interior nucleon has 12 other nucleons in connection, hence binding energy of 12 into 1 by 2 into U equal to 6U, which means that if a single nucleon is surrounded by 12 other nucleons, that nucleon has the binding energy of 6U. If all the A nucleons in the nucleus are supposed to be in the interior, the total binding energy of the nucleus would be EV equal to 6U into A. 6U is the energy possessed by the single nucleon. If the nucleus is having A number of nucleons, this is mass number, proton plus neutron number, the total volume energy is equal to 6U into A. This 6U may be replaced by a constant A suffix V, where AV is having the value of 12 MeV. This is called volume energy term. Second term is surface energy term. As we know that nucleus is spherical in shape, the surface area of the sphere is 4 pi r square. R equal to R0 A per 1 by 3 is the radius of the nucleus. If you substitute this value here, 4 pi R0 square A per 2 by 3 we can get 4 pi R0. These are all the constant. The value of R0 is 1.3 Fermi. 1.3 into 10 power minus 15 meter. 4 pi, all are constant. So the affecting factor is mass number to the power 2 by 3. If the atoms are present on the surface, the binding energy decreases, because while describing the volume energy term, we have assumed that all the nucleons are present well within the nucleus. All are considered as interior nucleons. Suppose the nucleons are present on the surface of the nucleus, they are not attracted by all other nucleons in all the directions. They are subjected to only the downward attraction. Above the nucleons, no force is acting. Now read out this statement. The nucleons on the surface of the nucleus interact with nucleons on one side. Upward interaction is not possible. Likewise, the surface tension force in the liquids, the surface energy is acting. Hence, energy of the nucleons on the surface is less than the interior nucleon. Suppose a nucleon is present well within the nucleus. If it is an interior nucleon, the energy possessed by that nucleon is 6U. If the nucleon is present on the surface, its energy is reduced, because the surface nucleons are not surrounded by all other nucleons in all the directions. The volume energy term is derived based on the assumption that all nucleons are equally attracted on all sides. Therefore, the surface nucleons reduce the total binding energy of the nucleus. So that this is nuclear radius, this is the formula for surface area of the sphere. As you know that nucleus is spherical in shape, finally we may get this term 4 pi r0 square a power 2 by 3. These are all constants, therefore surface energy term is proportional to a power 2 by 3. To remove the proportional sign, we are using this constant b. Hence we may point out that the surface energy decreases the binding energy of a system. Next term is Coulombic energy term. A nucleus contains Z protons. If the whole charge on Z protons is uniformly distributed within the nuclear volume of radius r, then due to the mutual repulsion, the binding energy decreases. This is called Coulombic energy. EC equal to 3 by 5 Z square E square divided by R. Here E is a constant, 3 by 5 constant. The affecting factor is Z and A power 1 by 3. We know that R equal to R0, A power 1 by 3. Therefore, this Coulombic energy term is proportional to, you may write, EC is proportional to Z square divided by A power 1 by 3. To remove the proportional sign, we are introducing constant C. The value of the constant is 3 by 5 E square divided by R0. This term is also decreasing the binding energy of the system. Next term is asymmetry energy term. In heavy nuclei, the number of neutrons is always greater than the number of protons. That is N greater than Z. Suppose N equal to Z, number of neutrons in a system is equal to number of protons, such a nucleus is stable. If N is greater than Z, the number of neutrons present in a nucleus is greater than the number of proton. This N minus Z is called as asymmetry. If N is equal to Z, that is symmetry. If the number of neutrons is more than that of protons, then the term N minus Z is called asymmetry. Now read out this statement. In heavy nucleus, the number of neutrons is always greater than the number of protons. Nuclei with N is equal to Z are highly stable, as the number of neutrons increases, the nucleus acquire an asymmetric character, due to which a force comes into play, reducing the volume energy. That means the binding energy is reduced. This reduction is directly proportional to the square of the excess neutrons. Excess neutron means if n is greater than z, n minus z will provide the excess neutrons. Directly proportional to square of the excess neutrons over the protons, and inversely proportional to the total number of nucleons. Total number of nucleons is given by the mass number. So the asymmetric energy is proportional to n minus z. This provides the excess of neutrons square divided by the total number of nucleons, that is A. To remove the proportionality sign, we are introducing a constant D with a negative sign, because this is also reducing the binding energy of the system. N minus Z whole square divided by A. We know that A equal to Z plus N. Therefore, N is equal to A minus Z. Instead of N, if you put A minus Z, we can get A minus 2Z, because replace N by A minus Z. So this is A minus Z minus Z is A minus 2Z whole square whole divided by A. This is called asymmetry energy term. And final term is pairing and shell energy. Nucleons tend to exist in pairs. Hence, the nuclei with an even number of protons and even number of neutrons are highly stable. Nuclei with an even number of protons and an odd number of neutrons, or an even number of neutrons and an odd number of protons, are less stable. Even stable, odd even, or even odd less stable, odd unstable. The nucleons in a nuclei exist in the form of shells. Similar to arrangement of electrons in different shells and subshells, nucleons are arranged, which can be described in the nuclear shell model. The nucleons in a nucleus exist in the form of shells, and the shells are filled by a certain number of selection rules. Considering both effects, the volume energy is tailored in this form. See that actually the volume energy is tailored because of this pairing energy term. Volume energy is reduced, which means that the binding energy is reduced. Here we are going to point out the pairing energy and the shell energy. The pairing and the shell energy reduces the volume energy. So the pairing energy EP is equal to delta into A power minus 3 by 4. Here we may point out the pairing energy EP is inversely proportional to A power 3 by 4. Then to remove the proportionality sign, we are using the constant delta. If you bring this to the numerator, this is written as A power minus 3 by 4. The value of delta is positive for even, negative for odd, 0 for an odd A. Now we are going to combine all the terms. This is surface energy term, is a positive quantity. Then this is volume energy term, which is always a positive quantity. This is surface energy term, having a negative sign. Coulombic energy term, this is also negative. Then this is asymmetric term, negative term. Then pairing energy term, plus or minus. Here negative sign indicates that the binding energy is decreased with the help of these three factors. Here we are using plus and minus with respect to the number of nucleons. Whether it is even combination, this delta is having positive sign. If it is odd combination, we have to take the negative sign in our account. So that these factors are actually affecting the binding energy of the nucleus. The volume energy term actually increases the binding energy of the nucleus, but the rest of the terms are reducing the binding energy of the system. But the last term, pairing energy, is positive for the even combination and negative for the odd combination, 0 for an odd mass number. So this is a graphical representation. We are going to understand more about this energy term. This is total binding energy, which is in the positive quadrant. Volume energy term is in the positive quadrant. So you get binding energy per nucleon. But the symmetric term, surface energy term, coulombic term are present in the negative region. That's all about the Weizsäcker's semi-empirical mass formula.